And in today's episode, among other things, you'll see China has just shown the world its robot brain platform, which allows humans to control machines using only their thoughts. And Elon Musk doesn't want to be left behind and has shown the world his Neuralink, allowing people with paralysis to control wheelchairs using his brain chip. A so-called space station was sent to the bottom of the sea in the form of a habitable underwater capsule. A perfect simulator. Let's see how artificial intelligence is learning to walk in the virtual world. And this, of course, so it doesn't make mistakes when it's here in our real world. South Korea presents robotic clothing that dresses the user on its own. Yeah, my friends. Let's understand all this and a few more things about new technologies.
Hola.
Hello, impressed ladies and gentlemen. I'm Realidad Impresionante, and you're watching Realidad Impresionante. Here's a quick update on how things are going. As I shared earlier in the community tab, we've had some problems with the weather here. Yeah, just to be clear, the studio here was slightly damaged. There were some problems. Maybe if you look at the camera angle, you'll see that the monitors aren't connected to the internet. I put a generic image there so we wouldn't have nothing, so it wouldn't just be that basic black screen. Anyway, it's okay. Despite the problems, it's okay. We had some damage here in the studio too. My house, thank God, is all fine. Nothing happened. Now, here in the city itself, there were a lot of problems. Yeah, more than 50% was destroyed. Thank God there were no fatalities as far as we know, right? I don't know if it was a typhoon, tornado, or something like that. Yeah, we still don't know, but it was bad. There's a lot of damage in the city. When we walk around, everything is destroyed. Yeah, today's the 4th or maybe the 5th day. 5th day today. The power returned yesterday. Without electricity or mobile data, I couldn't record. Now I've got a little mobile signal on my phone, so I can do a little bit and see what's going on. For everything I need to research for the channel, I have to go to a neighboring city. So it's pretty complicated. It really messes up our logistics. But let's keep working until things go back to normal, right? There's no estimate for when the internet will be back. At least the power is on, so I can record in the studio, edit, and then rush to the city to spend the whole day in the neighboring city. Yeah, looking for more material. Downloading the videos, getting everything ready to bring back to my PC and finish this video for you, okay? So I kindly ask you, okay? The channel is going to take a slight hit. That means my income drops, and it affects the way I work. Anyway, everything gets really complicated. I need your like. I'm not asking you for money. I'm not asking you for help with anything. Anyway, I just need your like, your share if you can. And leave a comment about technology or about what happened. I know you won't. If you do that, YouTube will recommend this video to more people, which will help us. Thanks. I appreciate your support. Now, let's get to the video and skip the small talk. It's a fact that humanoid robots are learning to walk, to manipulate objects, and even to talk to people in an increasingly natural way. But despite the advances in artificial intelligence and robotics, these robots still have trouble interpreting human thoughts and translating them into reliable actions. Now, the Chinese brain-computer interface company Brian Kuo claims to have solved this problem to some extent with its new integrated platform, Cerebro Robo. Instead of relying solely on keyboards, joysticks, or voice commands, it has developed a platform that is capable of directly interpreting the brain activity of the human user. To be able to control robots and maybe, which is even more important, right? To better understand and comprehend our behavior, human behavior. Presented during the World Artificial Intelligence Conference in Zandai, the RAARC. The platform combines brain-computer interface with artificial intelligence, a system that the company is describing as the first integrated brain-robot ecosystem. The goal is not just to control machines with your thoughts, but to create a much more intuitive way for humans and machines to interact. It all starts with a cap-shaped device. This is equipped with electroencephalography sensors and records the small electrical signals that are naturally produced by our brain. All of this is done through the scalp. Unlike brain implants like Neuralink, for example, this method here is completely non-invasive and doesn't require any surgical procedure. These captured signals are sent to artificial intelligence algorithms, which are able to identify patterns related to the user's movement intention. Instead of interpreting words or pre-programmed commands, the system tries to understand what the user, the human, is trying to do at that exact moment. Once this intention is identified, it is converted into digital commands capable of controlling different types of robots. During the demonstrations, the platform was used to control robotic arms, humanoid robots, and even robotic dogs. In one of the examples presented, the robotic arm was able to identify the human user's intention and pick up objects like an apple or a cup, and it did this using only the signals captured by the EEG. But according to Brian Coe himself, the greatest potential of this technology may not be in controlling machines. It seems that the real goal is to solve one of the biggest bottlenecks in current robotics: the lack of high-quality training data. Today, robots need to observe thousands of human demonstrations in order to learn tasks that are simple for us. Even so, they often still can't fully understand why a person chose a certain movement. By directly recording brain activity during demonstrations, the company believes it is possible to create much richer datasets. This way, gathering human intention and the movement performed by the robot, and virtual simulations in a single learning process. And this allows training artificial intelligence systems that will be able to understand not only how a task is performed, but also what was the intention behind that action the human wanted carried out. Naturally, there are still very important challenges to be overcome. EEG-based interfaces pick up much weaker signals than brain implants, making interpretation much more sensitive to noise and interference. In addition, Brian Coe has not released detailed results about accuracy and performance in real-world environments, which means that the technology will still need to go through independent validations before it can be widely adopted. Even so, the proposal points to a very interesting change in the future of robotics. In fact, we're going to see now how Elon Musk's Neuralink has just accomplished something very similar to what happened in China. Let's take a look. After allowing people with paralysis to move a cursor on a computer screen, Neuralink has now taken another very important step. For the first time, participants in their clinical study have demonstrated the ability to control a motorized wheelchair using only brain activity connected to the technological chip implanted in their heads. The demonstration is still part of an experimental study, okay? But it shows that Neuralink's brain-computer interface is already starting to move out of the lab environment to solve real challenges in human mobility. The core of this technology is Neuralink's brain implant, N1. With about 23 millimeters in diameter, approximately the size of a coin, it is implanted directly into the motor cortex, the region of the brain responsible for planning voluntary movements. From there, more than 1,000 ultra-thin electrodes are distributed throughout that region of the brain, and they record in real time the electrical signals produced by the neurons. Even when a person has completely lost movement in their body, these areas of the brain continue to generate electrical activity whenever they imagine performing an action. What the implant does is basically capture these neural patterns and send them to an artificial intelligence system that is trained to interpret the user's movement intention. And instead of moving the muscles as usual, these commands start to control a virtual cursor that is displayed on a screen. And it's precisely this cursor that becomes the control for the wheelchair. By imagining pushing it forward, the user makes the wheelchair move ahead. Mental movements backward make the equipment go in reverse. Right and left control the turns. Meanwhile, different positions also allow the user to adjust the seat and the backrest. The farther the cursor is moved from the center, the faster the wheelchair goes. During the test, the participants traveled through indoor hallways and outdoor areas, using a camera installed on the wheelchair itself. The image was transmitted in real time to the navigation system, allowing the user to follow that exact path while controlling all movements solely through brain activity. Another very important aspect of the project is safety. Instead of keeping the command active indefinitely, the cursor automatically returns to the central position when the user loses focus. As a result, the chair gradually reduces its speed until it comes to a complete stop. This behavior reduces the risk of involuntary movements if the user's concentration is interrupted while driving. The demonstration is part of the clinical study called PRIME, which began back in 2024 to evaluate the safety and performance of Neuralink's brain-computer interface. According to the latest updates from Elon Musk's company, several people around the world received the N1 implant by June 22. Earlier this year, Neuralink reported 21 participants with implants in 4 countries, while its separate G Prime study in the United Kingdom had recruited 7 patients by May 2026. Despite the promising results, they emphasize that the technology is still in the clinical investigation phase and has not yet received final approval from regulatory authorities for commercial use. Even so, the progress makes it clear that brain-computer interfaces are evolving very quickly and far beyond just computer control. For the first time, they are now beginning to restore physical autonomy to people who have lost the ability to move. And I keep wondering when it will be possible to control an exoskeleton so that people who really have mobility issues can truly regain their autonomy, right? Even though it's still not natural yet. And yes, if this technology keeps evolving at its current pace, controlling these machines with just your thoughts could stop being just a lab demonstration and become part of the daily lives of thousands of people who need it. Another technology, this time involving contact lenses, has also evolved a lot, you know? The first lenses were made of glass and were uncomfortable for all-day use. However, today, contact lenses are made from soft materials like silicone hydrogel and are practically unnoticeable in the eyes. But there is still a problem that affects millions of people. People with irregularly shaped corneas usually need to rely on custom lenses, which can cost hundreds of dollars and require several appointments. And it can also take weeks for them to be ready. Now, researchers at the University of Waterloo in Canada have developed a technology that promises to completely change this process. Using 3D printing and a new type of silicone, they were able to manufacture fully customized lenses in about 20 minutes. The principle seems quite simple, but it requires enormous precision. First, a detailed mapping of the patient's cornea is performed in order to create a three-dimensional digital model. With this information, the software designs a lens whose inner surface exactly reproduces the shape of that patient's eye, while the outer surface is adjusted to provide the necessary optical correction. Next, this model is sent to a 3D printer, which is capable of manufacturing the lens layer by layer. The biggest challenge is still the material. Silicone is considered one of the best materials for contact lenses because it is flexible, biocompatible, and allows oxygen to pass through, characteristics that are essential for maintaining eye health. However, it was not compatible with conventional 3D printing processes. And to overcome this limitation, the researchers developed a new hydrophilic silicone formulation that can be printed with great precision without losing its mechanical and optical properties. Another obstacle arose from additive manufacturing itself. Objects produced by 3D printing usually have small irregularities between the layers. They are imperceptible to ordinary people, but enough to cause discomfort and impair vision in a contact lens, right? The solution was to apply an ultra-thin coating that eliminates these imperfections without altering the custom shape of the lens, preserving both transparency and optical precision. The first laboratory tests show very interesting and promising results. The lenses showed the expected biocompatibility with ocular tissues and optical performance very similar to that of commercial lenses already available on the market. Now, the researchers are preparing to start a new phase of testing, this time under real conditions, and to move forward with the patent process before future commercialization. And scientists have always seen ocean waves as one of the greatest sources of clean energy on our planet. But building equipment capable of surviving for years, facing storms, corrosion, and constant impacts without breaking, that's a big challenge. Now, a Swedish company claims to have overcome exactly that obstacle. Its electricity-generating buoy has just received the most rigorous certification in the offshore energy industry, bringing wave energy closer to its first large-scale commercial application. The most curious detail about all this is that all this technology was inspired by how the human heart works. Developed by CorePower Ocean, the C4 buoy represents a somewhat different approach from the various previous attempts to harness wave energy. Instead of simply resisting the force of the sea, it works in harmony with the movement of the water. With about 9 meters in diameter, 18 meters in height, and approximately 100 tons, the structure remains anchored to the ocean floor by a tensioned cable. Each time a wave lifts the buoy, this cable pulls it down again, creating a continuous up and down movement that drives a set of gears connected to an electric generator. The energy produced by the system is then sent to the mainland through underwater cables. But the real difference lies in a system called wave spring. Instead of working as a damper, reducing the movement of the waves, it acts as a smart spring that is able to amplify the buoy's oscillation when the sea is calm. This way, a wave of just 1 meter can generate a displacement of about 3 meters, and this significantly increases the amount of energy captured. During storms, the behavior reverses. The system becomes much more flexible, allowing the buoy to follow the movement of the ocean without suffering excessive impacts. And it was this strategy that allowed the equipment to withstand waves of more than 18 meters without any structural damage. The company's plan is not to use a single buoy, of course, but to install dozens of them in groups called core packs, thus forming power generation sites capable of supplying hundreds of thousands of homes. Unlike sunlight here on Earth, which depends on daylight or wind energy, which varies according to the winds, waves have a much more consistent behavior, offering production that is predictable almost all the time. For 25 years now, humanity has been living continuously on the International Space Station, a structure that orbits 400 kilometers above the Earth. Meanwhile, the environment that covers more than 70% of our planet's surface remains much less explored. But now, a British company intends to completely change this reality. It has just placed a new underwater habitat on the ocean floor, which may mark the beginning of a new era for ocean research. Despite the enormous advances in diving technology, scientists still face a fundamental limitation. Each expedition requires long periods of descent, ascent, and decompression, causing much of the time to be consumed just getting there and back. This drastically reduces the time available for research and makes long-term studies extremely expensive and complex. Jeep developed the Vanguard specifically to remove this obstacle. This habitat was installed at about 17 meters deep, near the Florida Pier, and represents the first human habitat in the open ocean that is built, tested, and deployed in the United States. With just over 10 meters in length, it was designed to accommodate up to 4 of the so-called aquanauts, and during missions lasting 5 days or even longer, functioning as a permanent operations base on the seafloor. The great advantage of this concept is that researchers no longer have to start each dive from the surface. Living in a pressurized environment, they can make several daily excursions to explore reefs, test equipment, and monitor ecosystems, all without having to repeat the entire decompression process between activities. And this significantly increases the useful research time, something that was extremely difficult with conventional techniques before the habitat. But the Vanguard is just the first step. It will serve as a testing platform for an even more ambitious project, which is called Sentinel. The proposal is to develop modular habitats capable of keeping teams living on the ocean floor for about a month or even longer, thus creating a permanent structure for scientific research, development of new technologies, and even astronaut training. Why not? That makes perfect sense, right? Because living in an isolated, confined environment and being totally dependent on life support systems presents challenges very similar to those faced in future space missions and to those already encountered up there, right? Years ago, it was even common to say that one of the biggest challenges in robotics was something that today is surprisingly simple. It's teaching a robot to walk without falling. Each new environment required weeks of testing, thousands of attempts, and a constant risk of damaging the equipment, which is very expensive, costing hundreds of thousands of dollars. But a new technology promises to completely change the whole approach. Training a robot through reinforcement learning means allowing it to experiment, make mistakes, and try again millions of times until it finds the best strategy. This process works very well on computers, but it becomes extremely expensive when it happens here in our real world. Each collision or fall can break sensors, actuators, and mechanical components, which are quite expensive, as mentioned. In addition, restarting the test requires time, maintenance, and high costs. The solution found was to transfer practically all this learning to a virtual environment that reproduces our physical world with an unprecedented level of fidelity. The first step of this technology starts in a surprisingly simple way. The human operator goes through the environment just once, using a regular camera. From these images, three-dimensional reconstruction algorithms turn the place into an extremely detailed digital model. Instead of creating just a visual representation, the system also reconstructs the geometry of the environment, allowing the robot to see obstacles, surfaces, corridors, and objects that might be hidden, almost in the same way a human does. The reconstruction now lets artificial intelligence see an environment that much more closely matches the physical space it will face later. It's in this virtual scenario that reinforcement learning comes into play. When the training is over, the technology known as zero-shot transfer comes into play. Instead of reprogramming or adapting the system again, the navigation policy learned in the simulation is transferred directly to the physical robot. Instead of weeks or months of on-site calibration, most of the training can be done even before the robot arrives at its destination. Getting dressed seems like one of the simplest daily tasks, doesn't it? But for millions of people who are already of a certain age, people with disabilities, or professionals who need to put on protective equipment quickly, this process can be a huge challenge. Now, researchers from South Korea and Stanford University have developed a technology that really seems straight out of science fiction. a garment that can almost dress its wearer by itself. The system uses small flexible structures, similar to vines, that are incorporated into the fabric itself. When they receive air pressure, they gradually move forward, pulling the clothing along the entire body while turning inside out during the process. Instead of pushing the entire structure forward, the robot grows only at the tip, continuously adapting its path to the shape of the person. As a result, the user can keep walking or even performing other activities, while the clothing automatically positions itself. Another important difference is that the system practically eliminates the need for complex control algorithms. The mechanical design itself does most of the work. The researchers believe that the first applications may appear in hospitals, clean rooms in the semiconductor industry, and emergency teams, where putting on protective equipment quickly can make all the difference. If you enjoyed this episode, please like and make sure you're subscribed. Your support really helps our channel, and we need it now. Thank you for staying with me until now, and remember to check that you're subscribed, okay? That's really important. Click on one of the 2 suggestions on your screen. You'll keep helping me a lot. I really need it right now, okay? Thanks. I'll see you in the next para. See you in a bit, okay? Bye-bye. Just click and I'll see you there.